Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will discuss section 5.1 and in particular, I will focus on the introduction to discrete random variable and how to use Excel for computations associated with these type of problems. So I will be working through problem number 5 on your online homework, section 5.1, and this should be very helpful for problem 1 on your weekly activity. Okay, so let's go ahead and take a look at this problem. You might have slightly different values as you work through this problem, but the idea will be exactly the same. We have the number of arrivals per minute at a bank located in the central business district of a large city that was recorded over a period of 200 minutes with the results shown in the table below. So we will be working with this set of data, and I already preloaded my data into Excel, but to do that you would just click on this rectangle and open it in Excel. So to save a little bit more of time, I already done that. So here's my data. I have my table with arrivals and frequencies just copied into an Excel spreadsheet. So now let's go ahead and try to make sense out of this problem. We have a variable x, that's a typical notation for discrete random variable. In our case, this represents number of arrivals per minute. Okay, and the values that it takes in this case is 0 through 8. So let's just pick one of the values and try to interpret it. So 3 and 35, what does that mean? It means that there were 35 minutes when within that minute, 3 people showed up at the bank, right? Okay. And then there were 22 times when we had 4 people show up within 1 minute, okay? So now that we know what this variable stands for, we can answer certain questions. So let's see what the first one is asking us to do. It says compute the mean number of arrivals per minute. And over here, I have your textbook opened. This is page 198. We have a formula that says that the expected value or the mean of the discrete probability distribution function, okay? How does that compute it? It is the summation of the values of that variable times its corresponding probability, okay? So now let's go ahead and use Excel to compute the mean of this random variable. The first thing we're going to do is construct the probability table, okay? For the first column, we just need to copy our values. So x accepts values between 0 and 8, okay? Then we compute the probability of each value. How do we do that? Well, we have frequencies for each of the outcome, and we have the total number of outcomes, which was 200 minutes. So we say equal frequency divide by 200. And this is our probability for event when there are no people showing up within 1 minute, okay? Then you highlight your cell, drag it down, we get all of these probabilities, okay? Now, for this to be a valid probability function, the total sum needs to be 1. Let's just go ahead and double check that that's in fact the case, okay? We have 1 as the total sum of all probabilities, so we've constructed this table correctly. Now we would like to compute the mean, so we're going to do the following operation, okay? Over here on the top row, I'm just going to denote what I'm doing, x times the corresponding probability, okay? And what are we going to do? We're going to take each of the value and multiply by its corresponding probability. Now, of course, for the first one, we get 0 because the value of the variable is 0. Okay, we'll drag it down. and we get all of these values that we now sum up. Okay, this is just me following the formula that it says take each value, multiply by its probability, and then add them all up. Okay, so we get 2.51. Okay, that is the average number of arrivals per minute at this bank. Let's go ahead and check if that is correct. Mu is 2.51. Type an integer or a decimal. Do not round. Okay. They like that answer. That's correct. We're good to go. So the next question says, compute the standard deviation for the number of arrivals per minute. Okay, let's go ahead and go to the next page. And here we have two formulas. Okay, we're going to use both of them. So here's one formula up here, formula 5.3, which is the definition of variance. Okay, and then also we have formula 5.4, which is computational formula for the variance of discrete probability distribution. It says shortcut. Okay, we're going to go ahead and use both of them. Okay, so how are we going to apply these formulas? Let's go back to our Excel computations. Okay, and the first formula says it's the summation of the difference between the value and the mean squared times the probability of that value. Okay, so I'm going to do it over here carefully. What we're going to do x minus mu. Okay, then we're going to square that separately. X minus mu squared. And then what I'm going to do, I'm going to take that value and multiply by its corresponding probability. Okay, so these are the steps that we're going to follow. Okay, to use the definition of variance to compute the standard deviation. So x minus mu, how do we do that? This is equal. First we start with 0 minus the mean. Okay, so the mean in this case is 2.51. You can just type it in, or you can just highlight this and make sure that you put dollar signs to reference the cell. Okay. All right, so now we're going to go and drag this down. Okay. So that's my difference, or my differences for what? The value and the mean. Okay, now we need to square this. Okay, that's easy. Equal, highlight the cell, times the cell itself. Okay, so now we're going to get all of these positive numbers, right? Okay, and now we need to multiply this by the corresponding probability. Okay, so this value times the probability. So we're going to go back here to the probability column. Click on that. Okay, and just copy it down. All right. Okay, so now we've done just this part right here for each individual output, right? So for each individual number. Okay, we didn't sum it up just yet. So once we sum up these values, okay, I'm going to sum up all of these. Notice they're all positive, as they should be, because we squared at some point. Okay, so we get this value of 3.4599, and what we've just computed. Okay, so let me make a note here. This was our mean, right? Expected value, and this value right here, this is variance. That is not standard deviation just yet, but we can find the standard deviation fairly quickly. Okay, so over here to compute the standard deviation, all I need to do is take the square root of the variance. Okay, and I would just use this cell right here because that will give you more accurate computations. Okay, so that's my standard deviation. All right, 1.86 So if I were to round it to 3 decimal places, that would still be 1.86, right? Okay, let's go ahead and plug that in. 1.86. Let's check our answer. This looks good. Okay, so now you say, well, what if I wanted to do the other formula? That's completely fine. So what does this formula say? It says, go ahead and square your values, multiply them by the probability, then sum this all up, and then subtract mean squared. Okay, we can do that. Okay, and we'll see if we get the same thing. So this one would be x squared times the probability, right? Okay, so that would be our original value times itself times the probability. Okay, we're going to go ahead and copy this down. All right, then we're going to sum this up. So sum of all of these values. And we need to subtract what? Mean squared. Okay, so we can just do this operation here. We squared the mean in that formula. You can square it separately, see what you get. Oh, look, we get exactly the same variance. This is also variance, right? We just computed variance. Okay, so notice I'm going to highlight these. Okay, so this is your definition formula, and this formula right here, that's what we call the shortcut. Okay, so let me highlight that one and centralize it. This is your shortcut. Yeah, either way, you get the same answer for variance, but once you take the square root, you also get the same answer. Okay, now which way you would like to compute your standard deviations and variance, that is really up to you. Now let's go back to this problem real quick. Let's see, where are we? So for this problem right here, I'm not asking you to do anything else, right? Just compute the mean and the standard deviation. But in general, we could ask you to answer some questions such as, what is the probability that there are exactly 3 people that walked in within a minute? Then the notation for that would be something like this: probability that x is equal to 3, okay? And then you look for this row right here. So you say, okay, that probability is equal to 0.175, right? Okay, what if it said something like, what's the probability at least 4 people walked in? Well, what does at least 4 people mean? Okay, so at least 4, so that's x is greater than or equal to 4, okay, greater than or equal to 4, so that's 4 or more. Well, what does that mean? 4, 5, 6, 7, or 8, okay, then we just sum up all of the probabilities that correspond to these outcomes. 4 or more, okay, we get this probability. Or I could ask you a question such as probability that at most 2 people walked in, at most 2, so that's x is less than or equal to 2, okay. At most means no more than 2. Okay, and then you say, sure, that is the sum of all probabilities up to the value of x is equal to 2. Okay, we'll highlight these 3 cells. So up to 2 means what? 0, 1, or 2. Sum up their probabilities, we get the following event. So here, this is exactly the value, right? Exactly 3. Okay, this one is at least 4, and the last one was at most 2. Okay, so your mean represents the average number of people that walk into this bank within 1 minute, and the standard deviation represents what? The spread of this distribution. Okay, so we can always look at the graph of this. If you go to insert and go to recommended charts and just pick the frequency, the bar graph, right? There you go. So you can see what this distribution looks like. Okay, where can I put it? Let's put it right here. So it's a little bit skewed, right? So we have this tail on the right, okay, which says what? Most of the data, most of the observations are kind of clustered, centralized on this site right here. So it's no surprise that your mean was, what, 2.51, because a lot of the high bars are right here. That's your heavy weight for the probability, right? And then over here, you don't have as much, so it makes sense that the mean is somewhere over here. Okay, again, this is not something you necessarily need to answer for this problem, but it's a good idea to make a connection of what we're learning right now and what we already know from the previous chapters. All right, thank you for watching.